Let's say that y is equal to 6 over x squared. What I want to do in this video is figure out what is the second derivative of y with respect to x. And if you're wondering where this notation comes from for a second derivative, imagine if you started with your y and you first take a derivative, and we've seen this notation before. So that would be the first derivative. But then we want to take the derivative of that. So we then want to take the derivative of that to get us our second derivative. And so that's where that notation comes from. It looks like you have a d squared, d times d, although you're not really multiplying them. You're applying the derivative operator twice. And it looks like you have a dx squared. But once again, you're not multiplying them. You're just applying the operator twice. But that's where that notation actually comes from. Well, let's first take the first derivative of y with respect to x. And to do that, let's just remind ourselves that we just have to apply the power rule here. And we can just remind ourselves, based on the fact that y is equal to 6x to the negative 2. So let's take the derivative of both sides of this with respect to x. So with respect to x, I'm going to do that. And so on the left-hand side, I'm going to have dy dx is equal to, now on the right-hand side, take our negative 2, multiply it times the 6. It's going to get negative 12 x to the negative 2 minus 1 is x to the negative 3. And actually, let me give myself a little bit more space here. So this is negative 12 x to the negative 3. And now let's take the derivative of that with respect to x. So I'm going to apply the derivative operator again. So the derivative with respect to x. Now the left-hand side gets the second derivative of y with respect to x is going to be equal to, well, we just use the power rule again. Negative 3 times negative 12 is positive 36 times x to the, well, negative 3 minus 1 is negative 4 power, which we could also write as 36 over x to the 4th power. And we're done.